H Company has just released a state-of-the-art browser use agent framework. Not only that, they open source the core models that are powering all of it, and they even published a research paper going over exactly how they were able to achieve such great performance. That's what we're going to be talking about today. I partnered with H Company to tell you about this launch because it's awesome, it's open source, and some of the technical details are very interesting. So the big product that's just announced is Runner H. It's in beta and free to use right now. You can use it. I'll drop a link down in the description below. And if you're not familiar with it, it's a way to give agents access to the web. You type in a task and they will actually browse the web and accomplish the task on your behalf. So let me just kick off an agent so you could see how it works. Then I'm going to dive into the open source models and the research paper. So here's what I'm going to do. Go to eBay and search for Pokemon cards currently listed for sale. Extract 10 Pokemon cards listed and create a Google Sheet where you add the cards with their eBay links. So I'm going to go ahead and click enter and you're going to see it start working. The best thing about browser use agents is that you can kick one off and then go kick another one off and a third and a fourth and a fifth and have them all running in parallel. So as part of this task, it needs to create a Google Sheet and it already asked me. So it says, do you want to connect Google Sheets? I click connect. And once I'm done authenticating, it will continue. All right, so it got started. Use Surfer H web agent to search for Pokemon cards on eBay. So first thing it's doing is coming up with what it calls a policy or a plan. And again, all of this is detailed in the research paper. I'll show you that in a second. Here you can see the different steps that are coming. It's thinking, it's going to actually click through. Here's the browser session loading up. All right, and there we go. This is a live view of Runner H actually operating. And we can see each of the steps right here. So thought, notes, web action, and you can actually scroll through all of the different steps. So you can see it is actually going to eBay and looking for Pokemon cards. Okay, so I'm going to come back to this in a moment, but let me show you about the open source models. Okay, so their open source models were released as a family of models, and it's all within the framework of what they're calling Surfer H, the cost-efficient web agent with open weights. So here are the weights right here. You can just click it and it comes with two main models, Holo 1 navigation and Holo 1 localization. Localization just means a model that kind of can determine where on the screen to click, the coordinates. And if you want to give these models a try on your own, go to Hugging Face, click the Holo 1 navigation, and you can actually input a UI image and give it a task, and then it'll actually output the navigation steps. So here's an example of that. If you input this image of a travel website, book a hotel in Paris on August 3rd for 3 nights, and thought, I need to select the checkout date as August 6th, 2025, and then proceed to search. There is the navigation step. Again, completely open source. So feel free to come here, download the model weights, extend it, fine tune it, whatever you want to do. Links in the description below. All right, now here is the research paper. Also, we'll link this down below. So we present Surfer H, a cost-efficient web agent that integrates vision language models. We pair it with Holo 1, which is a new open weight collection of vision language models specialized in web navigation and information extraction. And as I mentioned, it is state of the art on the Web Voyager benchmarks. Listen to this. When powered by Holo 1, Surfer H achieves a 92.2% state-of-the-art performance on Web Voyager, striking a Pareto optimal balance between accuracy and cost efficiency. The good thing about these models is they're small and efficient. And these are models that you could take, you can build stuff on top of, and they work really well. And H Company also released their own benchmark, open source as well. That is called the WebClick Evaluation Dataset. So first, why browser use agents? Why computer use agents? Why are these things important? Well, they talk about it here. However, there being agents, real world utility remains bounded by the available predefined tools and the engineering effort required to expand them. We live in a world in which the internet is built for humans. Mostly. And so the companies offering products and services on the internet don't always have well-documented and standardized APIs for agents to interact with. And so in that sense, we need web agents to interact with the website in the same way that humans interact with the website, by clicking, scrolling, highlighting, all the stuff that we do as humans with a website. Computer use agents have recently emerged as a new paradigm in which agents interact with software directly through graphical user interfaces. This approach avoids relying on custom integrations or APIs. And this is where they present Surfer H, a visual web retrieval agent designed to be easily trained through reinforcement learning techniques. Surfer H comprises 3 main modules: a policy, a localizer, and a validator. These modules are compatible with any VLM capable of proposing and evaluating actions, any VLM, vision language model. Our agent only uses screenshots from websites and does not require the document object model or the accessibility tree of the website. So it doesn't actually need to see the code. It just simply takes a screenshot, figures out what's on it, and then figures out the coordinates of the right button to click on. HoloOne is a family of lightweight VLMs specializing in taking and evaluating actions and localizing UI elements. Localizing means figuring out where to click. All right, so how does it actually work? So as mentioned, there are three pieces: the policy, the localizer, and a validator. The policy proposes actions that are executed sequentially. So that is, go to the website, scroll down, click this button, etc. Then web actions are executed in a browser by simulating human-like interactions. If the policy generates an action that requires interacting with a specific element on a web page, such as a like button, it generates a textual description of the element, and the localizer provides its 2D coordinates. Then when the policy emits an answer, it is passed through a validator. The validator generates feedback about the answer and decides whether it is suitable for the user. If the answer is valid, it is returned to the user. Great, it figured it out. It solved the task. Otherwise, the feedback is incorporated into the agent's memory, and the agent continues its execution until either completion or reaching a time or cost budget. So here's what that flow looks like. We give it a task, it comes in, it stores the task in memory, then it creates a policy, the list of steps. Here's what that looks like. Refresh, go to the URL, go back, scroll, wait, right, click. Now these XY coordinates in red are produced by the localizer. It looks at the screenshot and figures out where to click on the screen. Now the answer goes to the validator. If the validator says, nope, that's not quite right, it goes back, provides that feedback, stores it in memory, and then does it again. If it needs to continue using the browser, it does so, and then eventually the validator checks, hey, is the overall task completed? And if so, gives the quote unquote answer, basically what you asked for, the task completion. So let's look at some benchmarks. This is the click accuracy across models and benchmarks. So on the left, we have a bunch of different models. Here's Qwen 2.5 Vision Language, 3B Instruct. Here it was uGround, UI TARS, and the HoloOne 3B. These are all kind of relatively the same size. Then we have the slightly larger one, the 7Bs versus the HoloOne 7B. And as you can see, almost across the board, the HoloOne 3B wins. Same with the HoloOne 7B. It just outperforms the other ones. And the overall average, as you can see, is pretty substantially higher than the rest of the models on the list for the 3 billion parameter version. For the 7 billion parameter version, it has a nice win over the uGround V1. And so the HoloOne as a localizer, basically figuring out where to click based on coordinates, it is outperforming the other models as well. Here we can see that. HoloOne in black all the way at the top. And it's also priced really well. It's very small, very efficient. So here we can see average cost per run, and in black and red over here, we can see that it's all the way on the left and relatively high compared to the other models. So lower down on the X axis means lower cost, and higher up on the Y-axis means higher accuracy. So this is a really good place to be right here. Here we can see some more comparisons about the cost to analyze these images. So here's the cost per million input tokens, cost per million output tokens. And as we can see, the HoloOne series of models comes in at quite a discount as compared to the rest of the models. And right on the main page of the website, the fully HoloOne-based agents offered the strongest trade-off between accuracy and cost. Surfer H plus HoloOne 7B, 92.2% accuracy and only 13 cents per task. Surfer H plus GPT-4, remember, Surfer H, model agnostic, 84.3% at 71 cents, and Surfer H plus 4.1 mini, 88% at 26 cents. And to bring costs down even more, if you want to use the 3B version, you basically sacrifice a little bit of accuracy and you bring the cost down a few cents per task. Okay, now checking back to the Pokemon task that I kicked off earlier, here it is. Here's the final listing. This is a PDF exported from a Google Doc. Here you can view and edit this data in the Google Sheet. So if we click that, here's the Google Sheet that it just created for us. Here's a couple that said link not available due to capture. That's okay, but it got the rest of them just fine. So all of this happened completely autonomously. All right, so a few last things that I want to show you. One, you can actually select how much human in the loop, you want highly involved, moderately involved, and fully automated. That's kind of nice. You can upload documents directly and give it as context. If you click over to the Files tab, these are all the files that you've generated. You can also, again, add files here. Connections is really helpful. So one thing that you can do is connect RunnerH to all of the services that you use, grab API keys, grab authentication, but sometimes that's a little bit complicated. And so they have a bunch of built-in integrations, Google Sheets, Google Docs, Drive, Notion, Slack, Zapier, and you can use these simply by checking this and then just authenticating directly with the website. And then one thing that I think is really cool is they're gonna have payments coming soon. So you can add your payment credentials and have the agents pay on your behalf. Now, one other thing that they announced is Tester H, which is in private beta right now. You can apply for access, and it's a way to automate QA and testing of your website, your app, whatever it is, easily. So here's what that looks like. Here's Tester H in action. So you can write your tests like so, given, navigate to Airbnb on the specific page, scroll laterally and click on the first photo with an orange bed. The image of the orange bed is displayed. So you can define your tests just like that, hit go, and now you have an automated QA test. So H Company just dropped a bunch of cool stuff. I'm really excited for you to try it out. Open source, always very appreciated by me. I'll drop links to everything in the description below. Thanks again to H Company for partnering with me on this video. If you enjoyed this video, please consider giving a like and subscribe, and I'll see you in the next one.